So today we will quickly see how the joins and concatenation works, right? So join, as the name says, these are just joining, two different data frames together. So that is what join is all about. So how can you join two stuffs together? That's it. So if let's say this is let me show in Excel quickly.
Joining means like hookup, huh?
Join means adding two data frames together horizontally. That is known as join. So let's say this particular yellow area is data frame A, and it has certain so some ID, name, and salary. And let's say there is another data frame like this, which has ID and department, right? So these are two different data frames. Now, join will allow me to merge these two things together, or join these three together and create one master file which will have all these records or all those informations, or on whatever condition. Let's say we need few from here, few from here. So all of that can be clubbed together here. So Ranjit, do you know SQL?
No.
Okay, so you have no idea about joins, is it?
Yeah, I'm very new now. I didn't learn SQL.
One second then. Let me please give you the basics of it. So if I open this, let me open any of them. No, this is join. So this is join. So what these are circles, right? So these circles are individual data frames. Just think it from that perspective.
Okay.
So each circle is a data frame. Right, let's say A is data frame something and B is some other data frame. So join is something which will basically join two data frame and it will make one out of it. Like essentially you are adding two data frames together based on certain conditions. Now that is the most important part. So you are doing this join based on a certain condition. So like the example here, if these are two different data frames, and if they have a common element between them, ID, let's say this is ID, this is also ID. So we can use this common element to join between these two. So that is something we can do. Okay.
So vertically, the data will be joined together, huh?
It will be horizontally.
Horizontally. Okay.
So the new element will have ID, name, salary, and department. So this will be after join, this will be the final data frame.
Okay.
After joining these two.
Understand. Okay.
Right. Now, what will happen to number of rows? Let's say this has these many rows, right? And this has only 3 rows.
Okay.
So the point here is, let's say this is, let me go into detail. This is ID 1, 2, 3. Right. And this is department, let's say IT, this is civil, and this is some other mechanical. Something like that. So here, based on ID, let's say this was ID 1, this was ID 2, then some other thing 1, whatever. So these whole thing will come here. This entire piece will come here. And whenever there is a match with this one, the department, those values will be populated and rest will be blank. So when it is doing this join, so one having a match with one, then IT will come here. This will be IT. 2. So 2 is having a match, then civil will come here. Like that. So 54, there is nothing common. I don't have the department for 54, right? So this will be a blank. Let's say this will be like blank. So
Okay.
that is how joins work. It looks into the common element, and based on common element, it does the join. If there are no the advantage of having common element is you can align, this two rows closely.
Mm.
That is advantage. Let's say this is person something. So this person is from IT. So if we can join by common IDs, then only my this row will be relevant. Otherwise, this will come here with different IDs with different salaries. So this will not make sense then, right? So that is what join is all about. Now, this one where the red color is on the the left hand side, that is known as left join. That means whenever you are joining two elements, or let's say two data frames, this is the common element, right? The middle part which is common in both, that is the common element, or let's say that is the common key. Okay, because that is present on both the data frames. But what I need is I need all the elements from A. I
Okay.
need all the elements from A, not the elements from B, because that is what my need is. That is what the requirement is. Now, once you start working on these joins, you will encounter various type of scenarios. So this is a type of scenario which we will call as left join. The opposite will be your right join. So these are type of inner joins only, because so usually there are two joins, inner and outer.
Mm.
So all of these are inner joins, excluding the last one, which is an outer join, the full red one, which where I'm taking all the elements of everything.
Okay.
That is my red join. Yeah, outer join, sorry. And inner join is only the common elements. Let me. So I don't have anything, any document, hence I'm just checking it here. See, here it has given, I think, a good example. So consider the following two tables. So this is a student data, this is a student data frame, and this is a student course data frame, right?
Mm.
So what is the question? The question is both are connected by one common key. So what is that common key? It's roll number.
Mm.
Roll number is the common between these two fields, between these two data frames. So what essentially we have to do, we have to add these two together. As simple as that. Yeah, on this. So once these two were added, this is how it looks like. Now, yeah, so these are the different types of joins that we have. It's same with Python and SQL. Inner join will take only the common element. Left join, right join, these are part of inner join only, and there is something called full join, full outer join. These are the main things. So as the image says, image showed there, inner join are only about the common elements which are present in both the tables. It will essentially take these two. Yeah, the picture here shows. So this is table one, this is table two. Inner join is about only the common elements.
Mm.
It will take only the common elements. Now let's look at how the inner join. So this is one. Let's look at example of inner join. Understand working this query will show the name and age of students enrolled. Name and different. From student course. Which one is student? This one, not what? Student and student course. So inner join will just give you the common elements, the common ones which are present. 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 is not there. Yeah, I think it will give only these 5. 1, 2, 3, 4, 5. So that is the common between these two. Only those records will come here.
Okay.
So that is what inner join is all about. Similarly, there is left join, right join, and other types of joins as well. Now, for our case, let's do something. Let's quickly create a data frame. Let's create two data frames, so it will be easy for us to, So how are we going to create data frames? With the help of dictionaries. So first we will create dictionary, name, so there are three names, right? So this is one column, and name, ID, let's say this is another column. This is numerical to 34, 14. Okay. So this is one. EMP, let's say this is the employee is equal to PD dot data frame of PD is not defined. I have to run this import statement first, then only this will work. Data F is will be in capital. Yeah, let's say this is one, and let's create another one. Dict one here instead of name. Let's create location. Let's say these are location names. The IDs are dict one, employee is equal to this, and uh, location is equal to this. Yeah. So we have two data frames, right? One is employee and one is location, right? So this is how the employee looks like. This is how the location look like. So what we have to do essentially, we have to add them up. We have to join them. Let's say there is a need where I need to pull all the employees from a particular location. Now I would not be able to do it, right? In that case, I would not be able to do it because these are two different things. Let's say the superstore data sets. So the superstore, let's say this has all the numerical fields and the the profit discount, these all were into a different data frames. In that case, the first job would have been to add these two together and then do the operation. Similarly, first I have to add them together. Now, how will I add them? Based on the common elements. Now, that is what join is all about. So, how we will do it? EMP1 is equal to so can you see my screen? Hello.
Yeah. Ah,
Okay. So see, in Python we will be using the merge keyword. So merge is all about join.
yeah.
Okay, so I just come here and see, the merge or data. So this is that shift tab thing. So this will give you the details of what exactly you want to do. And sometimes also they specify some, formulas as well. So usually if df1 and df2 are two different data frames, then what it does is, if I have to merge this, so usually data frame dot merge, and within bracket you have to specify the second data frame. In short, that is the condition. So that is what we are going to do. So emp1 is a new one. Emp is the older one. Dot merge, within dot I will put location. Now what is one thing? So I have to, so this is the frame. I want the merge to happen between these two. Now I would need a condition which is on, like on what primary key I want to do the join. Or let's say if I do this now, by default, it's going for an inner join. or if I specify here on ID. Yeah. So this is what I'm going to get. So this is a left, this is an inner join, not a left. So this is an example of inner join. So what it is doing, so what is that inner join? So try to remember from the circles, Venn diagrams, only it's fetching the common element. So what is the common element? If I'm going based on ID, then only 34 is the common between these two, right? Only 34. So this particular entry is the common one. This particular entry is the common one between these two data frames. Hence, I am getting only the common one. So that is an inner join. Now, what is a left join? So left join will give you everything from the left hand side, but nothing from the right hand side. So left inner join, if I do, so it will be left on ID. How? Sorry, it will be left. See, the good thing here is, so what is happening? So this is a left join. Now, until now, we were just using one condition, on. So on is the common element, the primary key. So we call it primary key or the common element between them. Based on that particular field, we were just doing the join. But here, what we are trying to do, we are trying to do a left join. Left join means the table that I have specified, that will be the master table. So this is on the left hand side and this table is on the right hand side, location. So the need here is, I want everything from this table and only the common elements from this table. So that is what left join this thing is all about. So here only common elements or rows. But for left, all from the left table and common from right table. These are the only ones that will come here. Now see here, the employee table. Let's have a look. So this is the employee table. So the employee table has come. Name ID. So the entire employee table has come. And for location, I am getting only one for
Yeah.
the common element, because that is the element that's value I have on the other table, right? But the rest of the things are missing. So that's why these are nan. So nan are none other than missing value. Nan is just a missing value. So that is what a left inner join. Right inner join is the same thing, but just that all from the right table and the common from the left table. As simple as that. So how just it will be replaced by right? It's happening. So this is the location table. So everything from this table I'm getting from the right hand side. So location, yes, I'm getting all three. IDs, yes, all three. And only the common one which is there in the left table. Now, as per ID, as per the common element, only Sam is present in the left table. So I'm getting Sam and these two are blank, right? Ranjit, you following, right?
Yes, yes.
So that is the thing. So that's the type of joins we have, inner join. So these are the mostly these left join and inner join are the ones heavily we will use. Now let's try the other one. You know, this one we have left, right, outer, inner, and cross. Let's try this one. Outer first. How would be outer? And I'm just trying this out. Yes. So outer join is the picture, if you remember, where everything was highlighted. So outer join was like, you know, this one, where it takes everything. So that is full outer join. Outer join means it doesn't matter if A or B matches or not. I want everything. I want everything. So see here, full join creates the result set by combining results of both left join and right join. The result set will contain all the rows from both the tables. See, this is the interesting part. So for the rows for which there is no matching, the result will contain null values. Now come here and see what it has done for our case. So it has bought everything. all the IDs, all the elements, and whenever there is a not match, a missing value, it just placed as null for them. So have a look at the employee and location. So the employee has this John, Sam, Martin, John 12, Sam 34, this one, and Martin 14. These three are from the left table. And OL 22, GS and OV, OL, GS, OV. So OL, GS, OV, 22, 34, 64. So these three are from the left table, from the right table. And whenever there is a missing value, it's fetching that value. Otherwise, it's just pressing null for the elements where it does not have a value. So that is what a full outer join is doing, right? So these are like cases where we will not be needing this easily, but these are like good to know things, like, what is this outer join? So it's just pulling everything. Outer join will not only look at the common elements, but it will look at everything it has and it will just put them together. So now we have seen how to do the join between these. But my question is, for now, the ID was common. What if the ID's name was different? Let's quickly create two sample this thing. This is ID1 and this is ID2. This is employee 1, this is location 1. Right. So we have created two new data frames, right? This is employee 1 and this is location 1. So the thing here is the common key's name is different, right? The common key's name is different. So if I try to create a new data frame out of it, emp is equal to emp1 dot merge with the help of location 1. Now, two primary conditions. How means what type of join I want? I want a left join. And on. On means on what common element I want this join to happen. But the problem here is the common element's name is different. So it has ID1, it has ID2. For that, there is a way out, which is left on and right on. So whenever your element name is different and the name is not common, in that case, I have to write this condition. So left on, that means on the left hand side, what is the name of the common element? That is ID1. And on the right on, what is the name of the common element? ID2. That is the condition that I have to write. So EMP2. Now this will work. So what I'm going to do, so what I have done is, so I have, taken the similar approach, just that the names is different. The left hand side has this and the right hand side's name is this, and essentially it's the same thing. So that's in short about, what is a join. Now we know if the common element is not present, then that's how we can proceed. If there is no common element, it will join everything without, right? So if these two are two completely different things. Now, let's say this is name and ID, and this is okay. So take this example. So these two are just two completely different things, right? So EMP3 is equal to, let's say, EMP1 dot merge of LOC1. It will not run. It's saying no common element to perform the join. However, if we say is equal to outer situations like this, so for that we have to use a concatenation statement, because what merge is doing, so merge was adding these things together, right? So what if we have no common element? So in that case, because the most important here is this on element, so this on key is the most important thing, this on. So on will tell you based on which common element I want this join to happen. Where it went, it's over here. Yeah, this one. So column or index level name to join. these must be found in both data frames. If on is none and not merging or indexes, then this default to the intersection of the columns in both. If on is none, so let's put none. No, it's still not working. No common elements to perform. So there has to be some common element between them, otherwise this would not have happened. So whenever the common element's name is different, then we have seen what are the wayouts we have using left on and right on. But without, if we don't even specify that and we tell Python to do a join, it will simply throw an error. It will say, like, this join is not at all possible. That is what it's going to do, right? So
Yeah.
that is what it's going to do. So without any common elements, it's simply not going to work. So that is one thing on this. So just a few things you should remember. Dot merge. So that is the statement that we use to join. So dot merge, or let's say data frame dot merge to join two data frames. And there are certain things on. On is based on the common element. Now, if there are more than one common elements, then we have to use it with the help of a list. Like we were just using one column here, right? Left on, or right on, something like that. What if the common element is a combination of two elements, like location and ID both, or ID and phone number both? So in that case, that would have been in the form of a list. So inside the list, you just specify the column names. Like, second would be ID2, something like that. So it will take this combination as the common key. So for scenarios, it will take this combination as the common key, and then it will try to do the join. So that is on the on. And there is one more, which is how. So what how will do, how will essentially do what type of join you want, what type of join you want. And these are like outer, inner, left, right, and so on and so forth. So these are the three essential things that you should remember. Okay, one last thing is, what if common common elements name differ? In that case, left on and right on, left underscore on and right underscore on. Right. So if the common, like here we were just showing ID1 and ID2, the name is not common, name is different. In that case, we have to tell Python that the left common element will be based on ID1 and the right common element will be based on ID2. Then it will consider these two as the same element, just that the name is different. And uh, what else? No joins without any common elements. That is the last thing that we have seen, right? So these are few things that we should remember. And for joins, these are the essential ones. Now, this is join based on a condition, right? So these are joins that are happening based on certain common elements or common conditions. There is something called concatenation. Concatenation also happens in a similar way. Let's see how concatenation works. So the elements we had were like EMP and LOC. So EMP1, or let's say EMP4 is equal to PD dot. Now concat comes under PD. PD is the panda's name.
Hmm.
So it comes under this. So just go here and join. Objective is the name of the key. Yeah. Consider, okay, let's consider a data frame. It will be easy. Yeah, let's say df1 is a data frame and df2 is another data frame. Then all you have to do just pd.concat within a list. You just have to specify the element's name. So what if we do like this? We just put emp comma loc and emp4. If we try to see, this is what it will do. So concatenation is something which is also happening horizontally, but it's also happening vertically, but this is happening without any common element. And that is the reason the same is getting repeated. Like 34 is the common between these two, but it is getting repeated because it is essentially what it's doing is just if the if the columns are common, it's just appending things together one after another. You following me? So if this is one data, let me just give you name, let's say some 12, 13, 14, and it has some names. Yeah. So let's say this is one and this is another 12, 15, 17. So let's say these are two different data elements or data frames. This is one, this is one. So what concat is doing, so concat is taking this whole thing and it's keeping it here. Then it's taking the second data frame. So the first thing it does is it checks whether the element names are matching or not. ID, yeah, this is common. Location, no, this is not common. See here, that's why this thing has come different. So let's say this name is also similar. Let's assume for now. So for both the data frames, let's say the names, the column names are same. So that is the first condition concatenation will check. If the number matches, if the name matches, then it will simply append. It will take this and it will append it here. As simple as that. It will not check for duplicates or something else. It will just add these two things together. That is what pd.concat will do. However, on the other hand, for joins, what joins was doing, join was looking for a common element and join was happening on horizontal side, right? Join was happening on horizontal side where on one we had 3 columns, on one we had 5 columns. So we were just adding columns based on the common key. But here the join is happening, but it's happening vertically. So we are just adding together. Let's say there is some other data set, like this. So in that case, if I do a pd.concat again these informations it will take and it will just append them here. So that is what pd.concat will do. This is all about. Now, what if the column name is different? Let's say, let's just delete all this. Let's say this is name 1, name 2, and this is something else, location. So all these are different, right? So now if I try to do a pd.concat on this one, first it will take this element and paste it here. Okay, good. Second, it will come here and see, okay, IDs are matching, name is not there. So what it will do, it will take IDs, it will append them at the ID column. Name is not there, so it will create a new column called name2 and it will take these elements and put it here. So now see, we have some missing values. So these will be nans, these will be nans. Similarly, like this, these will be nans. Okay, now let's say there is another pd.concat. So what it will do, IDs is matching, again it will take the ID and it will append it at the ID position. And then it will see location. Location does not exist. It will create a new column called location. And all the values will come here in this. And these alls will be your missing values. These all will be your missing values. So this will be the final result of the concatenation. You understood?
Yeah.
So that is how concatenation happens. So now if you come here and see this, so are you able to look at, right? So on one table, we have name ID and other, so sorry, on one we have name ID and another we have location ID. So finally we are having three columns, name, ID, location. ID is populated because ID is the common, but name for three we have names, for three we have missing. For location, for three we have names, these three, for three we have missing. So that is how the concatenation works. Clear on this one? Or
Yes.
any doubts?
No doubts.
So now, if we have some, missing, so these are few of the things that we can try out, but rest of the things are not really needed. Axis by default, it will be 0 for row wise. So you remember, like last time we saw axis, this thing, just remember it. Axis is equal to 1 for columns and axis will be your 0 for rows. Now here the operation is happening on a row wise. So every rows are getting added. Hence the axis is by default will be 0. But let's say, let's do some experiment. Let's try to see what happens if we play around with the axis here. Axis 1. In that case, what is happening? See, the funny part is, in that case, the concatenation happening, but it is happening horizontally. It's not happening vertically, right? So if I come here, so axis is equal to 0 will go like this in this direction, top to bottom. But axis is equal to 1 will go in this direction, left to right. So first it will take this, next it will come at this, it will place them here. So this will be the final data set. This will be the final data frame. So that is what it's doing. So whenever you change axis is equal to 1 to axis is equal to 0. So axis is equal to 0 is going downward. Axis is equal to 1 is going in this direction. So that is how we can play around with data. That is how we can add, delete, or do whatever operation we want to do. So most important thing would be we should know what exactly we need, what is the intention, right? What exactly is the need? So if we know what exactly we need to do, we can leverage things accordingly. Like if it needs a concatenation, if it needs a merge, like if let's say you have data stored in multiple databases and multiple tables, and there are some common elements present in them. So to solve those kind of situations, you would always use a merge, which is join. You have to join them based on the common element, a left join or inner join or whatever.
Mm.
That is always you have to do. But let's say there is a scenario where you have access to some, transactional data. Now, transactional data every day you have to just add them up. So there is no need to join, there is no need to, have a common element. So every day the number of columns will remain same. Let's say transaction ID, transaction date, and transaction amount. So every time there will be an append. So at the end of every day, you have to take those many rows and add them to the previous day. So for to solve those kind of scenarios, you will use a concatenation. You will use a concatenation, where concatenation will not look at so many complicated things. It will just take, if the elements are common, it will just add them up. If the elements are not common, it will just add a new column and put missing value. That's it. That is how it will work. So
Mm.
that is all about joins and concatenations. And trying to remember if there's something else on drop and all of that we have seen. So axis, just remember this one because this will be beneficial in long term. Just remember this will be the, the ground truth. in Python. Axis 1 for columns and axis 0 for rows. Every time this will be like that only. So that is on the joins and concatenations. And so we can take, so tomorrow what we can do is we can take some sample records and we can do. So do you think it needs more practice or we can jump onto something else? Because
Do
this
one or
is
two
the,
samples.
hmm?
Let's do one or two samples so that I will get some good understanding. I'm understanding the things, but I need some practical, no? So after that, we can move on.
Okay. So that the thing is getting a ready-made data set is, that is first thing that we have to do. Otherwise, we have to write it. So that will be the pain point. And you have to think of a scenario.
Merging and join.
Here it does the same thing, but these are ready-made data sets. Now the thing is you have to see if these things matches or not. If the elements does not match, you wouldn't be able to do a common join in them. So that's the point here.
Simple thing is fine, no?
Hmm?
Like simple Excel is fine, no? That we can also do by ourselves, no? That just we need some
But yeah, with
like
Excel,
mm,
how can you want to manually upload this Excel?
no, that then we will need some coding, no? Manually upload means we will not get the extract data.
Yeah, exactly. We have to upload it. So there are two ways. Either you write the codes manually on Python,
Mm.
like this way using a dictionary, where it was here only, no? I was writing, yeah. This is one way of creating a data frame. Else you upload a CSV or a Excel file directly. So that
No,
way
yes.
it will take it.
But anyhow, in practical in workstation and all, CSV only we are going to work on. So manual data we are
Mostly CSV.
yeah, mostly CSV. Yeah.
CSV or Excel depends. So this is how you can, okay, let's take this one only. Okay, the DF is there, no need to write anything. So DF dot shape. First, how big? Oh, this is pretty big, 8399.18. So if I do a basic concatenation, what this will do, this will eventually be added up. This will be multiplied. This into 2, those many number of records will be there. So if I do that is equal to pd dot concat, within a list you just put df and this will be in angular brackets. Now df1 dot shape. Okay, df1, this is equal to dot df1 is equal to df, oh, between two data frames, right? So here create one more, df1 is equal to df dot copy. So that is one way we create a data frame. df1 is equal to df dot copy. Now here df and df1. So and let's name it df2. So df2 dot shape will be this. So what this has essentially done is this has essentially added things up.
Mm.
Right? This has essentially added things up. Now remember the column names. The column names have not changed because these are the same columns. It has
Mm.
just been appended vertically,
Okay.
right? So df is one data frame, df1 is another data frame. So for our case, it's just a copy of df, but still df1 is a new one. So these are two data frames. So if I concatenate these two, it will eventually create a third one, which is just the double the number of rows, but the number of columns are same. Now, what if I add now df with, the existing, this one that we have created? In that case, what will happen? The rows will increase by 3 and the column will increase by 4. That is what is going to happen. So emp5, if I do like this and df2 and here I make it df3. So df3 is equal to pd dot concat df2, that is one data frame, this one, and employee 5, this one, emp5. So now if I run this, okay, one thing, axis is equal to uniquely valued index numbers. Oh, this has something to do with the index now. This has something to do with the index now. What is that? Index of df2 dot index. Yeah, something to do with this one. Yeah,
A huge.
something to do with this one. See, that is a problem with randomly because these are not meant for these things, right? These are not meant for example showing. So that is the thing. But yeah, I mean, in a way, this is how the things will work. If you know, so for concatenation, just for adding vertically and horizontally, but joins for specific cases. Joins, okay, let's uh, some join examples in Python. These are all string joins. It's coming. Okay, it has, I think, given some sample. Okay, let's try it out. Let's delete this one. Here, import numpy as np. Now, why I need that? Because here the user has, okay, this is one thing. Every time if you want to manually create a blank space or a missing value, it has to be through numpy.nan. So that is the only way out. It has to be through numpy.nan, right? Uh, like we have seen here in our cases, we are getting missing values. Now, these are not user created, these are system created.
Correct.
Python has not been able to find a relevant common element. So instead, Python created a missing value. But what if we want to create something on our own and we want to have a missing value? So in that case, we have to use numpy.nan.
Mm.
That is the way out. And here, what it's doing is just randomly creating some numbers. So let's see here. So let's say this is a list is equal to np is equal to list. Now within list, what np dot, this has not been executed, np dot random dot, here it is random n. So what, random n. So let's say I want 5. So if I put li, so what this will do, this will randomly created some numbers. So every time you run it, the values will change. Every time you run this, the values will change. So how to fix it? Using this random.seed. So what seed will do here? So np.random.seed. So this will, it's more of like a counter, so regulator. So if I put the seed value as let's say 15, so that means every time I run this, the random numbers it will generate for 15 seed number, the random numbers will be same. It's not going to change. See, now I'm running these, the values are not changing. For 15, I'm getting these values. So this is more of like a regulator. It sticks all these elements to 15. And same goes for some other elements or, you know, some. So that is what seed is all about. Seed will help you to, you know, store your randomly generated numbers. And seed is needed every time you use a random number because these are random numbers. Every time you execute it, a new numbers will come. So let's say you want to do some analysis and every time the number changes, then of course you don't want to do that, right? Then what your analysis will not be stick to a particular direction. So for tackle those situations, we have seed. Now coming here, what this is doing, this what this part is doing essentially. So this part is first numpy is np, and then this is a left data frame. It has created 3 columns: transaction id, user id, and the value. Let's say this is transaction value, something like that. And there is a right data frame. It has user id and the color. So if I run this, it has been executed. Let's see how it looks. So left underscore df. So this is how the data frame looks like, and right underscore df. This is how the data frame looks like.
Okay.
So let's say the need is, let's say what I need to know here is, you know, I need to know the transaction value for the favorite color blue.
Correct.
That's the question I need to solve. Now, first of all, these two are not linked. So I have to create a link to solve that, to be able to solve that problem.
Okay.
So the point here is I have to basically bring them together.
Yeah, join together.
Sorry?
Yeah, we have to join together and we have to find out the value.
Yeah. So just come here, see what it was doing. So first, this would be on the left hand side and this is on the right hand side. Same logic will go here. So new underscore df, let's say the name is new data frame. New data frame is equal to left data frame dot merge within bracket your right data frame, comma, on. What is the common element between these two? It's user ID. So I have to specify user ID here. And what type of join I need? So I need a full join, right? I need a full join. I need everything to come together, not only this A or B or everything. So I want everything. So how is equal to outer. So if I do this, let's see what I'm getting. This is what I am getting. So first of all, we have to verify if this is right or not. So Paul is blue, Paul is not there. So Paul's all these elements should be missing value. So Paul is there, Paul's color is blue, but Paul's value and transaction ID is missing. So yeah, it's working. Next would be your Mary. Mary has blue. Mary does not exist here. Mary has blue color. Mary does not exist here. John has a red, and John is coming twice. John has B and C. So there should be two entries for John. So yes, John has two entries, red, and the transaction ID B and C and the value as well. Right? So John is there and Anna has a missing value. So Anna has a missing value in the color, but Anna has these values populated, transaction ID D and 2.24. So Anna has transaction ID D and this is 2.24. So I'm getting everything I needed, right? We clear right here?
Yeah, correct. Clear.
So this is what we wanted. We wanted everything because that's what the need is. Now the next thing was we wanted to see uh, red or blue. Let's say blue or red. Let's say for red, what is the transaction value? So for that, now the join part is done. Now we have to go back to the filtering part which we used to do. So this is DF, new DF. Now within that, what is the color? Let's say the color is red that we needed. So for red, what is the transaction value? So this is red. So DA, new DF, sorry, it's favorite color. So red is the value. So new DF, red, this will bring me all the red columns, red values from the favorite color.
Okay.
This will give me all the red columns. Right. And then now what is the value? 1.37. That is the value that I need. Now we can make it more customized. How? So first of all, if we want to access anything out of it, first we have to see what a type of data it is. This is a series. This is a series. So easy would be, let's store it somewhere, S1. And then let's see how the S1 looks like this. Now, can we access S1 elements? Yes, we can. dot I location. See here it says series. If you want to access a particular use it with using the I location. I location then position. No worries. Try that. I location then 0. Yes, I'm getting this 1. This is Johnson. The 2. Yeah, this is the transaction value for against rate. Now because there are 2 rates, so I've added a sum and this is what I'm getting. That was one of the problem we tried to solve, right?
Yeah.
You getting hang of it now? You getting clear?
Yes, yes, yes. Much better, clear.
Okay. So that's something. So these are like some practical use cases. Like, let's say this is transaction ID of credit card, something. This is the customer details with all customer account numbers and all. So first of all, we have to bring them all together. And not everything, only the relevant pieces of information. Now, this is just for example I showed you, but in a real world, let's say this will have millions of records and this will have millions of records. And if you bring these two together, it will take lot of time, lot of effort, resource and money. So you cannot run an outer join in a real practical world scenario. You have to go with an inner join or a left join. In that case, you have to very much selective about your final outcome. Right, like if you need blue and the common element, then what exactly you should do? Should you go for a left join, a nested join? Now those are things that falls under SQL, like different types of joins, one join within another. So what that will do, that will give you the fine-tuned result.
Hmm.
The only those 1 or 2 rows probably. So it's going to give you only those many records so that you can like this one. So instead of right, so what we did first, we added everything, then we filtered only this one. Instead, what if we just execute something like this, which will give me only the filtered element and not everything? So that is something we have to write. That is something we should come up with those logics in a real practical world scenario. And then essentially from this, you just extract what you want to extract. So that is something that, we have to keep in mind. And here, just let me add one more thing. This will be interesting and I missed it. Okay, so what this is doing, this is extracting all the rows where the favorite color is red. Where the favorite color is red, right?
Yeah.
I want to make some change based on that. I want to make some change based on that particular condition. So how will I do it? So until this part, it will remain same, but after this part, after the selection part, I have to mention the element name where I want to make that change. Let's say the user ID. I want to change the user ID to something else. User ID is equal to, I want to change it to something else. Same. No. Okay, this has been treated as a series. Okay, I'll show you later. So this is something else that we can touch base tomorrow. There are
Okay.
a few more things that we have to do. So basically the point is, we have seen using Lambda, right?
Yes.
How using Lambda we can, based on one column, we can change another column.
Hmm.
So this is something like that. Like this is something on that, but this is more of like, based on this filtering part, this based on whatever we have selected, if we want to make some change on these elements, like we have selected all the ones where transaction or where, color is red. And then for all those records, we just want to change the value to 0 or something like that. So that is what. So we can do it using Lambda, but this is one way of doing that as well.
Okay.
So yeah. So okay, let's have a stop now today.
Okay.
Okay.
Bye.
Okay.